Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everyone? In this video, I'm going to revise with you chapter or topic 8, grade 6. We have 4 points. We will cover 4 points. Prime numbers. Then we will talk about prime factorization. So first of all, prime numbers. What do we mean by prime numbers? A prime number has exactly 2 factors, 1 and itself. For example, 5. 5 has only 2 factors, 1 and 5. So most or all even numbers are not prime numbers. They are composite numbers because they are divisible by 2. So let me take an example. 8 has how many factors? 1 times 8 and 2 times 4. So this is not a prime number. We call it composite number because if you look at 8, it has 4 factors. It has 4 factors, 1, 2, 4, 8. So these are what we call composite numbers. By the way, factors of a number, so the numbers that we multiply to get this number, for example, if you want number 18, so it has, because it's an even number, so it could not be a prime number. The only even number which is prime is 2, because 2 has only 2 factors, 1 and 2. So the prime numbers is the numbers that is greater than 1 and has exactly 2 factors, 1 and itself. Look at 18. It has a lot of factors. 1 times 18. We also have 2 times 9 and 3 3 times 6. So these are the factors of 18. These are the factors of 18. So we should know and we should distinguish or differentiate between factors and multiples. For example, factors of 10, 1 multiply 10. Each number is factor for itself, by the way. And factors, and 2 times 5. So we can see that 10 has 4 factors. So it's not prime. And multiples of 10 is the product of multiplying 10 by any number, like 1 times 10, 10. 2 times 10, 20. Then 3 times 10, 30, and so on. You can say 40. These are the multiples. Now we have 4 points. Prime numbers, prime factorization. If the number is not prime, so we can find the prime factorization of this number. But what do we mean by prime factorization? Prime factorization is to write the number as a product of its prime factors. What I mean? Mostly we use factor 3. We use what we call factor 3. So if you have been asked to find the prime factorization of a number, you will make the factor tree until you find that all the factors became prime. Let me go back to this number 18. Now, if the question is 18 prime or composite? Of course, it's composite. It's not prime because prime number has only 2 factors. Now, if it's composite, we can find the prime factorization using factor 3. So 18, first I start by any 2 numbers, I multiply them, I get 18, except 1 and 18. For example, we can start by 2 and 9. Now, the number which is prime, we circle it as a sign it's a prime number, and the other number 9 is not prime because it has more than 2 factors. So we continue the tree, we make more branches. So 9, what 2 numbers we multiply them, we get 9, 3, and 3. So we circle 3 and 3 because they are prime factors. Now, so the prime factorization is a product of its prime factors. So only when we write the prime factorization, we write these prime factors. So the prime factorization of 18 is 2 multiply 3 multiply 3. Or we can write it 2 multiply 3 squared because we have 2 3s. So now we have an idea about prime numbers and prime factorization. Now look at this question. But what is the most important prime numbers we need to know? 2, which is the only even prime number, then because it has only 2 factors and it's greater than 1, 3. Now after 2, and we cannot choose any even number to be prime. All the even numbers will be composite. What about 1? 1 is neither prime nor composite. Now, so the prime numbers 2, 3, 5, 7, these examples only, 11, 13, of course not 15 because 15 has more than 2 factors, 1, 15, 3, 5, 17, 19, 23, and for example 29, 31, 37. So these prime numbers 41, 43, 47. What about 49? No, 49 is not the prime number. And the second point, we know now it's prime factorization. So we can find the prime factorization for any composite number. Any composite number, for example, 22. If you want to find the prime factorization for 22, we want 2 numbers, we multiply them, we get 22. So it's 11 multiply 2. Now, because they both prime numbers, so I stop here. So the prime factorization of 22 is 11 multiply 2. Now, the GCF, or what we call the greatest common factor. Greatest common factor, or what we call GCF. GCF. How do we find it? First, I give you advice, find it mentally. Try to find it mentally. You have to imagine what are the factors of the two numbers given, and they want the greatest common one, as its names apply. So we have many ways to find the greatest common factor. For example, if I give you two numbers, 8 and 12. By the way, the greatest common factor, if they don't have any common factors, so 1 will be the greatest common factor. The greatest common factor cannot be greater than the small number. Now we have two numbers, 8 and 12. So 8 is the smaller number. So the greatest common factor cannot be greater than 8. It could be 8. It could be the smaller number, but it could not be greater than the smaller number. Now, when you look at these two numbers, mentally you remember that they both have 1 and 2 and 4 as factors, and 4 because 8 is not a factor of 12. So I look at the 4. So I can use the way of listing the factors. So if I list the factors of 8, of course I start by 1, 2, 4, and 8. And the factors of 12, 1, 2, 3, because 3 multiplied by 4, then 4, then 6, then 12, because each number is a factor for itself. Now, if I want to mention the common factors, here we have 1, 2, and 4. But the question about the greatest common factor, which is 4. This is the greatest common factor is 4. But how I use, if I stuck in any question, how I use prime factorization to find the greatest common factor? Because I may forget one of the factors in this way, in this listing the factors. So I may use the prime factorization. First, I find the prime factorization for the two numbers. So 8 will be, I start by two numbers. If I multiply them, I get 8. So I put a circle on the 2, this prime number, and I continue I'm sorry guys, here 2 multiply 4, of course, 2 multiply 4, 2 is a prime number, so I circle it. 4 is a composite number, so I need to continue, because the prime factorization is you need to find the prime factors. So 8 is 2 multiply 2 multiply 2. It's better to write as what? As power. It's 2 power 3. 2 power 3. Now, what about 12? It's 3 multiply 4. 3 is a prime number, so I circle it. 4 is not a prime number, so I continue. It's 2 times 2, so I stop now. 2 is prime, and this 2 is prime. Now, I write the 12 as 3 multiply 2 power 2, because we have two 2's. Now, the GCF, using this way, we take only the common factors. So 3 is not common. We don't have 3 here. So we cross it, but we have 2. 2 is common. But in the GCF, I take the 2, which is the common, with the least power. So here we have 2 power 2, but here we have 2 power 3. So we choose the one with the least power, 2 power 2. Because we don't have any other common factors, so 2 power 2 equals 4. That's it. Now, the last point I'd like to discuss with you today is LCM, or least common multiple. Least or lowest common multiple. You remember that we've talked about the multiples, LCM. First, let me remind you that each number is a multiple of itself, and the multiples of a number is the product of multiplying this number by any number. So we can remember the multiplication table of this number. So if I want to mention the multiples of 6, I can say 6 times 1, 6, 6 times 2, 12, 6 times 3, 18, and I continue the table of 6, 24, then 30, so on. Now, the multiples of, for example, 8. 8 times 1, 8. 8 times 2, 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. So, my question is, we need to find what? Least common multiple. Do they have any, where they meet? By the way, the least common multiple, it cannot be less than the greater. So we have 6 and 8. It cannot be less than 8. It could be 8. It could be the greater number, but it could not be less than 8. So you need to remember this about the LCM and GCF. Now, the least common multiple, where they meet in the multiplication table, where they meet first time. So here, if you look at 24, they meet. So it's common multiple, and it's the least common multiple. If you continue the multiples, they would meet in 48, for example. But I want the least common multiple. Some students, they think that we just multiply the numbers. 6 times 8, 48 is the least common multiple. No, because it's a multiple, but we want the least common multiple. Some students, they can do it mentally. If I give you, for example, 6 and 8, so look at the greater number, 8, and ask yourself, is 6 is a factor of 8? Is 8 is divisible by 6? No. So I keep working on the greater number, only 8. 8 by 1, 8. 8 by 2, 16. 16 not divisible by 6. So I continue. 8 times 3 is 24. Is 24 divisible by 6? Yes. So it is the LCM. But some people prefer to use the prime factorization. So let me use this way, the prime factorization of 6 and 8. So give me any two numbers. 2 times 3, we get 6, because both of them are prime. So I circle them. So 2 times 3, this for the 6. And before 2 minutes, we mentioned that 8 is 2 times 4, and 4 is 2 times 2. So it's 2 power 3. So you can remember this. You put circles on the prime factors. This is the prime factorization. Now, to find the LCM using the prime factorization, you multiply the common first. 2 is common, yes? So I take here the common factor with the greatest power. So 2 is common, but here 2 power 3, here 2 power 1, or 2 power nothing is 2 power 1. So 2 power 3, I take 2 power 3. Then in the LCM, we need to take the non-common as well. So the non-common is 3 also. So 2 power 3 times 3. 2 power 3 equals 8. 8 times 3 equals 24. But most people prefer to find the LCM mentally or using what we call the listing the multiples. That's all for today. Thank you very much.